Welcome, welcome. So we are looking at how to make a little pivoting kind of joystick or something like that that is made out of a ball and a socket. So it's important to get this just the right size because this is going to get 3D printed, that it pops in there and will fit but won't fall out very easily and can still move. So it has to be loose enough that you can get it in, but tight enough that it doesn't fall out. So it's a little bit of a tricky thing here, just getting some numbers correct. Let's start going through this. The first thing I've done is I've created some variables because you might print this, and for your design being slightly different than mine, you might need to change some numbers and print it again. So I started two variables here, and you can click variable, type in the name of the variable, and then a value there, and that will allow you to easily change this value. So like if I wanted this ball to actually be 0.4 instead, it's going to quickly change the whole design, and it resized the size of this sphere here to be 0.4 in diameter. So create those two variables there real fast, and then I'm going to undo that, put it back to where it was. And then the second variable, so that's the first one is the diameter of this sphere. The second one, I found it to work pretty well at 0.95, so think of that like a percentage, 95%. So that's going to be something that we're going to use here in 1 second. I'll show you what that is. So 0.95 is going to be your percentage there. So the first thing I did was design the joystick, and this joystick or the ball part of this was just a sphere. So I made a circle, and then whatever is coming out of that is going to be the handle or whatever is attached there. So that is really up to you. I put a nice flat bottom on this so that when it's printed upside down here like so, that it prints really easily. If we were to look at this step, you can kind of see what that looks like. So it prints really easily sitting flat on that table. And we'll get to this revolve step in a second here, but the next thing I did here was to draw the cup. So what was going to be holding the ball. So there's a couple, the shape of this cup is really up to you, but we'll hide that for a second. So there's a couple important numbers here. This one and this one. So we were just talking about this 95% part. So as this ball snaps in there, it needs to be a pretty tight fit, but has a little bit of a spring to it so it can hold the ball in there. So this value here, this is the clearance that we just talked about, that clearance percent, that 95% times the diameter of the ball. So that when we draw this, if you see here, this from here to here, all the way across there, is 95% of the diameter of this sphere. So that it's just a little bit smaller, and it will pop in there and not fall out. The other number here is just the spacing between the ball and the outside cup, and I've found that to work pretty well at 0.005 inches. When you go to draw that, you will have a circle here that is the diameter of, I'm going to redraw it here just to kind of show you what I did. This is the diameter of the ball. And notice I just typed in B for diameter and it popped up there, and I pushed enter. So that's using that variable there. And then I'm drawing an arc. And that's the center line that I'm going to revolve around later. I'm drawing an arc that has a center point at the same spot here. and I'm drawing it like so. And then I'm putting a line from here to here. This is going to have to be the, well, you know what, I'll do that a little differently. I'm going to draw a line. I'm going to make it extra long for a second, and I'm going to add a point right there to find the center point of that line. And I'm going to drag that center point onto that line. So now I have that locked in there as the center point of that line. As you can see, it moves and stuff with that. So now I can dimension that, and that's going to be the diameter. And look, it pops up there with D for diameter when I push enter, and then I'm going to say multiplied by the clearance percentage. So that's going to be that 95%. So then when I push enter, it's going to multiply that, and then this is going to be 95% of that sphere there. And then I got one more dimension to do. It's the distance between these two. And as I was saying, that works out to be pretty nice fit at 0.005, so it's a pretty close fit there. I'll put that number somewhere else where I like it there. And after that, the rest of the design of the cup is really up to you. I'd recommend a nice flat bottom if you want to mount this to something, or if this is going into another piece, it's really up to you. If it's like an armor or whatever, I don't know what you're doing out there, but the rest of that part is the important part. The rest of it is really up to you. So I'll finish that, and when you're ready, this can be all your attachments there and all that good stuff too. And I'll extend that line up here. All right. And real quickly, I'll just do a revolve, and I'll say, ooh, that disappeared on me. There we go. Come on. There we go. There's my sketch. There's my sketch. All right. So I'm going to revolve this piece around this axis. And it looks like it didn't get that piece. There we go. So obviously that's not what you're going to want, but you kind of get the idea. And this piece will also get revolved, and there's going to be a nice little fit there. And that should pop together. And if it doesn't, we are going to tweak it a little bit and play around with it a little more. As you can see, my part has a lot of other pieces on there. I wanted the base piece to kind of lock into something, so I kind of had it like a twist fit and some other things I was playing around with. But that is the basis of what you're going to be doing there. And I would recommend pausing this video as you go, because there's a couple numbers in there that might be very important for you. Remember, the ball diameter can be something different. It doesn't have to be this size. It's up to you, as long as it's somewhat appropriate to fit in our 3D printer, not take forever. Enjoy. Hope this helps.